Question 2b. At alpha equal to 0.05, test whether the tree soil in which the bean plants were grown produce the same mean height. To test this claim, you can use ANOVA. As I mentioned before, ANOVA can be used to test whether the mean of the sample data, in this case height of bean plants, from 3 different populations, which is 3 different soil, are equal or not. So the factor involved here is the soil. The factor level is the different type of the soil in which the bean plants were grown. So the factor level, we can say that is 3 because 3 types of soil. To answer this question, there are a few steps. Step first, construct the hypothesis testing, which are H-null or null hypothesis and alternative hypothesis. For null hypothesis, mu1 equal to mu2 equal to mu3. Mu1 is the mean height of bean plants from population 1 equal to mean height of bean plants from population 2 and equal to mean height of bean plant from population 3. In other words, you can say that no difference in means for the 3 factor level. Alternative hypothesis, not all populations have equal mean. Step 2, the significant level is fixed at alpha equal to 0.05. Third step, determine the rejection region, RR. The degree of freedom for treatments, V1, equal to K minus 1. K is number of group, which is 3 minus 1 equal to 2. The degree of freedom for error, V2, equal to N minus K. N is number of total sample data, 14 minus 3 equal to 11. Critical value obtained from F distribution table. So this is the critical value I get from the F table. Before that, we write F with small letter number 2 for V1, 11 for V2 and 0.05 for alpha. So we look at the F critical value. This table can be found in this website. Okay, V1 is 2, V2 is 11, and the alpha is 0.05 here. So we scan this second column and fourth row, which is 3.89. So this is the critical number. So we reject H0 when F greater than 3.98. Must remember this statement. F, where we get from our calculation. So next step, step 4 is test statistic. To calculate F, use this formula. You can get from the ebook. Page 91, this is F value. Mean squared treatment divided by mean squared error. We can get all the value we have calculated before this from the ANOVA table. We just insert the value 0.35 divided by 16.07, so we got 0.0218. So this value is less than critical value. So for the next step is test result. Since the calculated test statistic value F equal to 0.0218, this number, less than critical value 3.898, fail to reject H0. So fail to reject means that the statement must be true. So the conclusion, we have strong evidence to say that the mean height of bean plants grown in different soil is the same. The claim is true. Let's say if we got the calculated F is greater than 3.89, so we must reject the H0. If we reject the H0, means that there is a significant difference in the mean height of bean plants from three different populations.